Oops. Okay, this is number 25 on the review for the test. And when I did this one this morning, it wasn't working out. So I wanted to redo this problem, number 25 on the review. So we have a car traveling at 44 miles per hour and its tires have a diameter of 25 inches. How fast are the car's tires turning? Express the answer in revolutions per minute and round to 2 decimal places. I'm going to shut this door real quick before I get started. Not all the way. Okay, so the formula that we want to use here is velocity equals the radius times the angular speed. And the radius is given to us. It says diameter is 25 inches, and that just means that your radius is 25 halves inches. And then we're also given that pi is equal to 3.1416. This is the rounded version of pi that they want us to use so that the answer will match exactly since they're rounding. And we're also given that the linear speed v is 44 miles per hour. So let me stop sharing so you can see this on my sheet here. All right, so this formula v equals r omega just comes from s equals r theta. And so s equals r theta. If you divide out by t, you get velocity, which is actually speed, equals the radius times omega. And plugging that in, we're going to get that 44 miles per hour is equal to 25 over 2 inches multiplied by your omega. And this is what we're trying to solve for. So I'm going to divide both sides by 25 halves inches. I just wanted to cover this problem before class. I'm recording, so, but it's related to the test. So anyway, omega then, when you divide this out, you get omega by itself. So omega equals 44 miles per hour. And then dividing by 25 halves is the same as multiplying by 2 over 25. And that's, of course, in inches. And the inches, I shouldn't write it there. The inches are in the denominator, right? So I should write the inches down here. And that's important because we're going to have to convert this answer to the proper units, because you'll notice we have distance in inches here and we have distance in miles here. So we're going to have to do a conversion. So we get that, and I'm going to write it like this: 45 miles is in the numerator, and whenever you see per, that means what follows goes in the denominator, so it's per hour. And of course we've got 2 over 25 inches. Now I'm converting inches to miles. And so what I'm going to do is I'm going to multiply by this conversion factor of 12 inches in 1 foot. And then there are 5,280 feet in 1 mile. And let's see, I want to convert hours to minutes. The answer is in minutes. So there's 1 hour is the same as 60 minutes. So that's another unit conversion factor. So it looks like we have everything, but the final answer, if you look here,
in the original problem, if you check out the answers, it's in revolutions per minute. So we need to get our units in revolution. And that's where the radians of the pi comes in place here. So
we want our final answer in revolutions. And if I didn't use this factor here, so 1 revolution is 2 pi. If I didn't use this factor, our answer would be in radians, okay? And you'll see that all the units cancel out. So miles cancel with miles, inches with inches, hour with hour, feet with feet. So all the units, except for revolutions per minute, are going to cancel. And that's the final answer, is in revolutions per minute. So when I go ahead and do the calculation here, I'm going to have 44 times 12 times 5,280. And then I'm going to divide by 25. And I'm going to divide by 60 and also 2 pi. So divided by 60 and divided by 2 and divide by pi. And I get 295.80 revolutions per minute. So let's go check and see if that choice is there. And it's not. Let's see here. Let's see what I did. So I took my velocity, which was 44. I divided by 25 inches. That's my radius to get my angular speed. And 1 revolution over 2 pi, 60 minutes. Did I divide by 25? Let me try here. I don't know why I keep having trouble with this. Let me try the calculator. And okay, we have, try it again. 44 times 2 times 12. I'm not sure if I multiplied by 2. I may have forgotten the 2. 44 times 2 times 12 times 5280. And then divide by 25. Then divide by 60. Divide by 2. And divide by pi. And yeah, I forgot to multiply by 2. So this time I got 591.60. That's better. I just didn't calculate it correctly. So let's go back there. 591. There it is. D is the correct choice. So that's how you do that problem. And I told my earlier class that I'm not going to have this on the test because of just the complexity. It's more of a physics problem because you have to struggle with all those units. And so I thought it's on the review and I wanted to show you how to do it, but it will not be on the test, that particular problem. So let's look at problem. There's another one I wanted to do. I think it was 45.
Do we have class today?
We do, but it's not required.
Okay.
So you can, I'm going to record the lecture and then send it out to everybody.
Okay. got it.
Yeah, sure. What's that? Okay, yeah, I'm gonna go through the whole review.
Okay, it's on the 5.4, I noticed there's more on the review, but it's only on.
Okay, okay. I'm gonna go through it. Yeah. Okay, I'm gonna set this one up and I'll let you finish it, but this is one that when I read it in my morning class, it didn't work out quite right. The surveyor is measuring the distance across a small lake. He has set up his transit on one side of the lake, 90 feet from a piling that is directly across from a pier on the other side of the lake. From his transit, the angle between the piling and the pier is 35 degrees. So, let me show you what the picture looks like. This is number 45. So something like this may or may not be on the test. But I want to let you know that I will draw the picture for you on the test so that you'll know what it's asking. So this is called the transit. This is the piling. And across from the piling is the pier. And they say the distance from the transit to the piling is 90 feet. And this angle is 35 degrees. So the way you solve this is we want to find this distance here, and tangent of 35 degrees is equal to opposite over adjacent. So it's going to be x over 90. And the units are going to cancel out because this is x feet over 90 feet. So our answer, well, actually our answer is going to be in feet, but so I won't put that like that. Now, if you solve for x here, you cross multiply. So think of this as x times 1, which is x, equals 90 times tangent of 35. So 90 feet times tangent of 35 degrees. And there you have it. I'll let you calculate it. But like I said, it's a little confusing the way the problem is worded. So I will give you the diagram on the test and you just have to take your feet and multiply by tangent of your angle, whatever that might be. So these problems are pulled, they're taken from a pool. So the numbers may be the same, but the wording, this is the picture that goes with it. All right, so those are the two problems I wanted to cover from my morning class, and I'm going to end this and then go ahead and start for my afternoon class. So here we go.